Nice to meet you. Hey, Patrick, George Bosson. Nice to meet you. We're here tonight to talk about a light's effect on health and well-being. The name of the lecture is Light and Us. And I developed this lecture over a period of 3 years, but the final formulation of it, and even though I was working on it this afternoon and changing it, was done under the auspices of Orgatec Omegalux. So the Orgatec Omegalux rep group is here tonight. That's Prudential, and I encourage you to go online and take a look at what Lawrence is doing there. Some very interesting stuff. This presentation is approved by the AIA for health, safety, and welfare credits. That's not an easy thing to accomplish because AIA requires their architects to amass a minimum of 4 health, safety, and welfare credits as a part of their stable of credits throughout the year. So I'm very proud that this was accepted by the AIA for that purpose. What we're going to be talking about is circadian rhythm and the biological, visual, and biological processes associated with circadian rhythm, how light affects attentiveness and sleeping patterns, and how lighting and biophilic design. Who here knows about biophilic design? Oh, Roger.
Because you taught me.
Oh, I do. And Rosie. That's my wife, Rosemary Allaire, the famous lighting designer. Just to give you a little background, I started in lighting in 1989 at Elliptipar. Who knows who Elliptipar is? Right? So I am a certified Elliptiparian. I am among you. I came in as an organization specialist to the company to work with Cy Shemitz, who was the president at the time. His daughter, Allie, now is. And rose through the ranks very quickly, became chief of operations, and was asked to oversee the engineering department for a while because, damn it, nothing comes out of that department. It takes 18 months to 2 years for me to get anything. So Cy sent me in to do my organization development thing. I had a master's in organization development. And during that process, I fell in love with lighting. Then that's all I wanted to do. The art and science of this wonderful craft. Just totally enamored. And when I realized that I wasn't going to be the president of Elliptipar anytime soon, I went off to California under the auspices of a corporation that no longer is around called JJI. And JJI owned 11 companies. Wayne Wofford worked for me. He was my first application guy many years ago. I'm so proud of you, Wayne, what's happened with your career through the years. I got a chance to be a part of a company called Lamb Lighting. Does anyone know Lamb Lighting? Okay. Well, Lamb, I didn't know what Lamb was. I had a catalog before I came out to California. In fact, John Shigarek, the Western Regional for Elliptipar, said, when you move to Southern California, make sure you live west of the 5. That's all I knew. That's all Rose and I knew when we came out here so many years ago, 18 years ago or so. So I started looking into the archives of the company to get a handle on what this thing was all about, where it was going, where it had been. And I discovered this guy by the name of Bill Lamb. And it turns out that Bill Lamb was like one of the most famous lighting designers literally in the world. He had written a book called Lighting and as a Form Giver, for architecture, one of the quintessential books. And to reinvigorate the company, I brought Bill Lamb back as a permanent consultant to me. So here was one of the top lighting designers in the world as my mentor, preceded by Cy Shemitz, another great mentor, to guide me through the process of architectural lighting. And one of the processes of reinvigorating Lamb was to have a really strong applications and sales group. And I was really hoping that Tom Schaefer would take that role. Tom is here tonight. He's the director of sales for Alight. And Tom ran off to GE, like within a few months, didn't you? Sure did. Yeah, I told you to regret it. And now I've had the opportunity to just recently work with Tom again. I founded a company called Alight. Who here knows Alight?
Yeah.
Well, that's gratifying. And when I founded Alight, I decided to set a course for the company. You know, we use astrological objects, stars, when we're out on the sea. And by triangulating with the night sky, we can find our way anywhere on Earth. So I came up with two design principles. One from, let's pay attention, one from my work at Elliptipar, and I called that optical elegance, the control of distribution of light. And then the second principle was architectural integration, so that we participate in the fulfillment of the design intent of the space. I left Alight a few years ago, and just prior to my leaving, I had Tom as the director of sales, had Mariah as the director of marketing, had Justin as the director of design, and I was kind of like the ambassador. I kind of went out and tried to inspire people with what Alight was doing. So I started reading. I was doing a lot of reading. And I discovered research that goes back now 25, 30 years ago. This was about a little more than 4.5 years ago. And it was about lighting's effect on health. And a lot of that came out of Scandinavia, where there's a terrible seasonal affective disorder problem. Who knows what seasonal affective disorder is? SADS. Okay, so SADS is a debilitating psychological, emotional state that 20% of the population in overcast climate experience every year. It's a terrible, terrible malady. And what came out of the research was, of course, initially the way to deal with it was drugs, and they found that caffeine was a very, very good drug for that. And I found that quite, remarkable. Of course, when you think about Seattle, there's a coffee shop on every block, at least every block. It kind of goes hand in hand. But what was found is, well, let me put it this way. There's not a lot of seasonal affective disorder on the west of the five. Southern California.
No.
So what's the difference between Seattle? The 5 goes all the way up to Seattle. What's the difference between the 5 in Seattle and the 5 in Dana Point, where Rose and I live? Sunshine. That's the beginning, Rose. That's very good. But it's sunshine. So, of course, the conclusion was that the difference is light. That's what makes the difference. So if we begin to expose people to high intensities of light, possibly we can begin to change and remedy the effects of seasonal affective disorder. Light therapy, which John Fox sent me an article on light therapy just the other day. Thanks, John.
You're welcome.
So that has been my passion for the last 4 years, is to understand this and to understand how to practically apply architectural, residential, institutional lighting solutions that make a difference in people's health and well-being, and that's what this lecture is all about. I'm going to move over to the podium here. I will unfortunately have to refer to my notes on occasion. But you've got the learning objectives down. And this is the story of light and us. From the very beginning of the universe, the photon was one of the first elements of the universe. And a photon, of course, is light. Does anyone know what this is? Is anyone familiar with this image? Gabe, you can't speak because I've already, I'm sorry. Go ahead, Gabe.
The radio frequency background of the universe?
That's right. It's microwave background noise. This is taken by the Planck telescope, which is a European Space Agency telescope. This goes back about 5 years or so ago when this image was taken. And it is an image of the universe as the universe existed 380,000 years after the Big Bang. The universe is 13.8 billion years old. So this is 13.4 billion years ago. This is the universe. And where do we come from? The universe. Earth is a part of it. But we come from the universe. And what you're seeing here is protons and electrons, and when they fused, creating hydrogen, they let off light. So photons, light, is a part of the very fabric of who we are. We are actually made of light these billions of years later. And this is taken by the Hubble telescope. This is the universe as it currently exists, with the Milky Way very prominently displayed in the foreground there. And this is, does anyone know what this is? This is a nebula. A nebula is the remains of an exploded star. And this is a part of the Milky Way. It's called the Helix Nebula. It's also got a nickname called the Eye Nebula. I like to think of it as the universe looking down upon us to remind us from whence we came. And of course, this is what Bucky Fuller called our starship Earth. This is how we make our way through the universe so far. There are other ways. And here is a depiction of the human eye. And the human eye is the portal of the mind and the body, but not only of that which we see. Within the eye, there are photosensitive sensors that respond to different wavelengths of light. But our eyes are not only there to process visual input, but also to stimulate biological functions. In particular, the part of the eye called the retinal ganglia cell, which has a photosensitive pigment called melanopsin. Light stimulates the retinal ganglia cell, which then sends signals to the hypothalamus for purposes of biological function. So for 5 million years, we've evolved under the sky, dominated by the sun during the day and the blue sky, and the moon and the stars at night. This is a depiction of Homo erectus. Homo erectus arrived on Earth around 1.9 million years ago and lived in a relatively dry climate, the savanna climate of Africa, close to the equator. a place where the sun almost always shines during the daytime, and where the light from the stars is so bright you can actually see shadows from trees and other objects in the environment. And it was around this time, it was really about 1.5 million years ago, that we began to use fire, whose warm red flame, and we're talking about candles today at night, and embers comfort us during the evening, warmth and color, and also protected us from predators. So we've been adapting to natural lighting conditions for a long time. The adaptation has literally created an internal system of regulation of our biological rhythm, which we call the circadian system, or the body clock. The body clock actually extends to the cellular level. By the way, one of the things that I didn't tell you about my background is that I attended the Lighting Research Institute at Rensselaer Polytechnical Institute to study light's effect on health and well-being, and we had a geneticist come in and talk about how the circadian rhythm of cells works as a part of our study. So the body clock extends to the cellular level by turning on and turning off hormones that affect many of the basic functions of our anatomy. And this cycle has about a 24-hour period. So in response to different wavelengths of light, our body clock, circadian rhythm, has entrained us as to when to get up and when to go back to sleep and restore ourselves. So this is dawn, where we grew up to be human. This is midday. This is sundown. And here's the night sky. For millions of years of our evolution, we've been exposed to natural lighting conditions. It's only from the past 100 years or so that we've been living with electrical light. And light has a profound influence on how we experience the world around us. The eyes are the beginning of that process. The retina takes in light, shadow, and color, and informs us as to what's going on around us. The optic nerve is connected to the eye's retina and relays signals to the brain that actually create pictures inside of our brain. But it's primarily the retina ganglia cells that send signals of light to other parts of the body for biological purposes. So this is a retina ganglia cell and a field of neurons. This happens to come from the mouse. And here's a retina cross-section of the retina ganglia cell connected to our optical nerve system, our nervous system, period. And this is a cross-section of the retina illustrating the retina ganglia cells, which are here, and also the rods and cones. Now, this is IS, we should all be familiar with rods and cones. But maybe you didn't know that there are 6 to 7 million cones in the retina. And of course, Gabe and anyone from Colorado would know this. And some 120 million rods. You may be familiar, I'm sure you are, with photopic, mesoptic, and scotopic light. Basically, photopic light are the cones, which are RGB sensitive, red, green, blue, that operate under fairly well-lit conditions. And then the mesoptic lighting condition is dimly lit environments where both the rods and the cones are working. And then in scotopic lighting conditions, or scotopic function, the rods are the only thing that are working. They're very, very sensitive to light. So when it's dark outside, we don't bump into things because our rods are working, super sensitive to light. In fact, I've been out on the Allagash in the winter, which is a river in Maine, and I had to go to pee so bad at 2 o'clock in the morning. It's tough to do that because it was like the ice had just broken, so it was very cold outside. But I finally got myself out of bed out of my sleeping bag and walked outside. There was no moon. It was a star-filled night, and I could see shadow. I could see shadow. I was stunned. So the retina ganglia cells, with the photosensitive pigment called melanopsin, you know, if you were all AIA people, we'd give you a test, but you're not, so we don't have to worry about that. Makes a contribution. These cells make a contribution to vision, but they have a direct connection to the suprachiasmatic nucleus, which is located in the hypothalamus. The hypothalamus is a part of the brain that all vertebrate species has, and regulate numerous biological functions. Vertebrates, by the way, showed up on planet Earth in our evolutionary cycle about 450 million years ago. Light goes into our eye, hits the retina ganglia cell, goes to the suprachiasmatic nucleus, goes into the hypothalamus, and to the pineal gland. And that has been going on in vertebrates for 450 million years. So let's go, what's happening here? So during our evolution, light would come into our eye and stimulate the melanopsin, photosensitive pigment, in the retinal ganglia cells at about 460 nanometers, 460, 470 nanometers, which is blue. Then the signal goes to the suprachiasmatic nucleus and then to the pineal gland, which inhibits the production of melatonin. So the pineal gland produces melatonin. What does melatonin do? Makes you sleep. So when the blue light hits the eye, the production of melatonin is inhibited. And the production of cortisol, which is the alerting hormone, kicks in. This happens really, the cortisol really peaks at around 8 o'clock in the morning, just prior to the time that I get out of bed. I wait for the cortisol. So these glands are regulating our biological function, and these glands learn to do what they do through the evolution under natural lighting conditions. So once again, these are natural lighting conditions. And the truth of the matter is that we no longer live under natural lighting conditions. We no longer work under natural lighting conditions, like these farmers used to do, which wasn't that long ago. We were an agricultural society. We work in situations like this. Billions of people spending 80% of their lives under these conditions. There's mounting evidence to suggest that poor lighting, confined spaces, that don't have windows, or window restricted, particularly during the morning hours, interfere with the healthy circadian pattern and contribute to obesity, diabetes, and other diseases. There are increased incidences, significantly higher increased incidences of cancer among shift workers, particularly among nurses. Some of the sickest people in our culture are the people that are taking care of us in the hospital at night. And depression is also exacerbated by spending long time under these conditions. And we talked about what seasonal affective disorder is, and what seasonal affective disorder is a result of a lack of light in people's lives. And the sufferers become depressed and anxious. It's very debilitating. There's now research pointing to the fact that these devices at night, what kind of light is coming out of that thing? Blue. So what's happening?
Melatonin being suppressed.
Melatonin is being inhibited. It's a natural condition. So how do you think this kid's going to sleep? Not very well. We're a terribly deprived culture in terms of sleep. And we've been pretty much told that, you know, that's the way it is. So think about all these buildings. You know, what are we going to do? Put a window in every building? You know, sometimes your office pod is, you know, 50, 100, maybe 150 feet from the window. So how do you deal with that? So you just got to live with it. It's the way it is. But there are some among us that are doing research in light's effect on health and well-being. And very solid research has now supported the fact that people that have a window in a hospital room recover 3 to 4 days quicker than other people, particularly in ICU. It's mostly done in ICU. So by introducing natural conditions to our environment, our built environment, we become healthier. So this happens to be a Ferrari plant in Italy. It kind of looks like a jungle. Another way to begin to rethink that which we have come to believe can't be changed is to introduce ourselves to an idea, and now it's a growing movement in the design community, called biophilic design. The whole idea of biophilic design is to introduce natural objects into the built environment. Here at the Ferrari plant, you can see it's very well illuminated. There are some windows over here. A lot of these workers are not close to the windows, but they do have the feeling of being outdoors by being inside of a planted environment, plant-filled environment. So this concept called biophilic design, and what I call circadian balanced illumination, will transform our built environments. This is this book called Biophilic Design. It was written by a guy that Rosie and I had an opportunity to attend a lecture of, Stephen Keller, who's a professor at Yale, emeritus in forestry. And he writes that people being in a natural environment learn better, work more comfortably, and recuperate more successfully in buildings that echo the environment in which the human species evolved. He says there are a number of ways to improve worker productivity and retention and reduce absenteeism. And one of the basic steps is to improve the availability of natural light. The term biophilia was first coined by Erich Fromm, psychologist in 1964, as he describes the human attraction to nature. The term was also taken to the next level by a Harvard University professor, E.O. Wilson, who described biophilia as the instinctive human need to connect with nature. We all know what it's like to take a walk in a forest or take a walk in a beautiful park. It is physiologically restorative. We can actually feel ourselves getting better. And that's the idea of biophilic design. By the way, one of the groups that's working on this is a group called the Terrapin Group in New York City. And one of the things that they found is this thing called stochastic movement. Stochastic movement. And stochastic movement is very, very fine movements within the periphery of the person's experience. And sitting at a computer for about 20 minutes begins to round out the eye, and it strains the eye muscles, which leads to fatigue and pain, vision problems. And what these people at Terrapin have found is if you can get up and just walk around and cast your view beyond 20 feet, within 20 seconds, your eye begins to relax, flattens out, and you can move back to your work. Now, I gave this lecture at an architectural firm, and they said, yeah, and that guy's going to put a computer 25 feet from us. So when we walk out, we can continue our work. So this is just one of the elements that we can introduce very easily into our built environment and create a physiologically restorative response to the people who are working. So I suggest that you go to Terrapin Group if you're interested in this. They've identified 14 patterns of biophilic design, and they've categorized them into 3 categories called nature in space, natural analogs, kind of biomimicry kind of stuff, and then the nature of space. So here's a biophilic design. Wouldn't it be nice to be able to work next to something like this? I love this stairwell. This would be a great place to take a walk during lunch or whatever. Obviously it's an evening thing. But I would hope that they also introduce like bird sounds in here, so you can, as you're walking up the stairs, kind of add to the experience, which by the way, they suggest be done, that kind of thing, suggest be done. I've done a lot of flying. This looks like about 2,000 feet as we're coming in for a landing. Great environment. And okay, so who knows what this is? Tom?
Johnson Wax headboard.
Yeah, that's right. And who's the architect?
Frank Lloyd Wright.
Frank Lloyd Wright. Right, so this is like 1936, 1937. One of the early biophilic designs. It looks like a forest. It's indirectly illuminated, so it has a canopy just like the sky. And they put in some plants. There's also a thing in the Terrapin Group recommends in terms of office furniture is to create random patterns with office furniture. It becomes more interesting, it's more visually engaging. And what do these supports, roof supports, look like? What are they?
Mushrooms.
Mushrooms, that's one thing. Evolutionarily, what do they look like? That's Alice in Wonderland. So we know what you did during the 70s.
Trees.
They look like trees, and in particular, they look like that tree. So we're back to the savannah. We're back to the roots of our evolution, who we are, what we are. And this is so important that we recognize this and introduce these concepts into the built environment. And what if we just thought that not only restructuring the environment, but bringing different lighting solutions to the built environment, what I call circadian balanced illumination. So biophilic design, and circadian balanced illumination. I think those are the key elements of the new built environment for health and well-being. So in the circadian balanced illumination consideration, blue light early on during the day, so that we're stimulated and our melatonin is inhibited as it should be. And then at night, nice warm and amber light to prepare us for our going to sleep, which is our period of restoration. That's what sleep is for. It physically restores us. And what if we gave people control over their lighting systems, their circadian systems. We talked about light therapy earlier. 500 lux, 50-foot candles, directly into the retina, relieves symptoms of seasonal affective disorder. Putting light into someone's eye relieves the effects. Or no, I'm sorry. Let me restate that. That resets the body clock. So 500 lux resets the body clock. 5,000 lux relieves symptoms of seasonal affective disorder. So we now know that we don't need that high intensity of light in order to relieve these symptoms or reset the body clock. We just need to go somewhere in the spectral power distribution and find the solution. And that solution is blue. Put on these goggles and reset your clock. Put on these goggles and you find your symptoms of seasonal affective disorder are relieved. And there's new research coming out, which is very, very exciting, particularly for shift nurses. One of my professors at RPI, Mariana Figueroa, is one of the top researchers in this field. And what she's discovered is that by exposing people to saturated red light at night, cortisol levels remain high, but melatonin levels aren't interrupted. So the circadian system continues as it was intended, but people are still alert and their cognitive acuity goes up. It's very, very exciting stuff. At least for me. So let's talk about artificial light for a while. This is fire, and we began to control fire around 1.5 million years ago. Probably pulled a stick out of the fire and it became our first portable light. And then 7,200 years ago, we came up with the animal oil lamp. Then 5,000 years ago, the candle. And then around 3,000 years ago, the kerosene lamp. This came out of the Middle East. Kerosene lamp started in the Middle East, most likely because you could scoop up oil right off the sand, put it in your kerosene lamp and burn it. And then the spermaceti lamp. Who's familiar with the spermaceti lamp? Ah,
It's whale oil.
yeah, it's whale oil. It comes from the cranium of sperm whale. And it is one of in fact, my son wanted to try to genetically produce this stuff. It's probably the purest lubricating oil there is. And when burned, burns white. So it was the first white artificial light from the cranium of a sperm whale. We know that well in Dana Point. And here's the electric light, of course, around 1836. That was introduced. Neon, 1910. And then around 1936, 1938, the fluorescent lamp was introduced. So our culture, our work culture, was living under electrical incandescent light for about 100 years before the fluorescent lamp made its entrance. And then in the 1970s, with the onset of the oil crisis, the energy savings race was on. And regulators encouraged lamp developers to produce lower and lower watt-consuming light sources, higher levels of efficiency, which ultimately has now led to a proliferation, big surprise, to me at least, how quickly LED came on and has just dominated our industry. And there was the corresponding, now remember, going back to the 70s, and Bill Lamb did a study on this for the energy department. Going back to the 70s, there was a corresponding reduction in the recommended foot candle levels in offices and schools. So with the reduction of foot candle levels, we unwittingly resulted in environments such as workspaces and classrooms where light levels were so low that they actually began to affect the well-being of the people that inhabit these environments. I think it's so bad that it's pretty much a mesoptic environment that many, many people work in and study in. So we talked about the fact that 500 lux, 50 foot candles into the retina, resets the circadian clock. However, our office targets are around 30 foot candles, 25 foot candles. School homes, children, are around 50 foot candles tops. Used to be 100, and in offices a minimum of 50 foot candles or more. And this is creating an unhealthy environment for the people that live there. Why can't we begin to change that? How many nickels more do we have to, pennies more do we have to squeeze out of energy? Why don't we start creating environments that look like this? Of course, this is a Japanese office environment, and I think they should have more plants. I mean, they're not being respectful of the biophilic consideration. But look at this place, full of light. We can do that now. Why aren't we thinking about it? And at least, let's go back to the 60s. This is taken from a Mad Men set. Boy, if I could only smoke back in the office.
Martini lunches.
Martini lunches. So with the advent of LED, we have opportunities to change our work environment. In fact, I was giving this lecture to some researchers up in Seattle, and I mentioned that this is the most revolutionary period of time in lighting since the candle. And one of the researchers corrected me and said, no, this is the most revolutionary period of time since we controlled fire, 1.5 million years ago. On the evolutionary scale, that's where we're at right now. That remarkable. And we can, it's not just intensities of light, but it's also the ability to be able to change color. You know, up until recently, the way you change color was to dim an incandescent lamp, right? I mean, that was pretty much it. And follow the black body curve, so you're going from a cooler source to a warmer source as it dims. It's very, very comfortable. And I think one of the reasons is because the evolutionary connection that we have to fire. It's about the same color temperature as fire. But we don't have to follow the black body curve anymore. I mean, that's old hat. We're not heating an iron rod anymore. We can go anywhere. We can go anywhere on the spectral power distribution curve. We can saturate, we can dilute, we can create environments that we can only create or generally create in the theater with gels and a billion lights. So we can have a saturated blue, saturated red. And through the application of biophilic design and circadian balanced illumination, we can transform our spaces. We go from static and boring spaces to spaces full of light and life, engaging and exciting spaces for our physiological restoration, tranquil, peaceful environments, and surround ourselves with wonder. And where does that bring us back to? It brings us back to our ancestral home. We yearn for this. We need this. And it is this community, the lighting design community, and the design community in general, that truly can make the difference in people's health and well-being going forward. And as Mariana Figueroa said in her article in A&I, where are the products? We know. Where are the products? Well, there are some products out there that can help us. I think this is Andy Warhol. I call it John Lennon's glasses. Well, one of the things that we can do is at night, we can begin to filter out the blue. So if you find yourself working on a computer at night, working on your iPhone or a tablet, put on a pair of blue filtering glasses. In fact, John Fox has developed a pair that are very, very, very effective. But you can also go on Amazon for a few bucks, have these glasses available to you. And there are new apps available. I have f.lux on my computer, which basically follows the day, your day, and at around 8 o'clock at night begins to filter out the blue in your computer, my laptop. And around 10 or 11 o'clock at night, it's damn red, but you can still work. You can still work. There's no blue left, so your melatonin production is not inhibited. So that's it. Thank you very much for the time that you've spent here. I hope this has been valuable to you. I take any questions you have. These are some of the material that was used in the development of this lecture. And you've heard of a light. Well, I'm launching a thing called B-Light. And I'm setting off to use my, I started in manufacturing back in 1983, lighting manufacturing in 1989. So I decided that I've learned a lot in Masters in Organization Development, and I have a lot to offer. I can help. I can help organizations, I can help individuals, leaders. We talked with Daniel, we talked about leadership earlier today, and management, and also coaching. How do I lead myself through life? So, yes, Ryan.
As a point of interest, just yesterday Apple released iOS 9.3 for anyone with an iPhone or iPad. That one of the main new features is night shift, which you can program it to automatically shift towards the red end of the spectrum.
That's great.
For this
That's
very
great.
reason.
Good for Apple. Good for Apple. Yeah, this is. I'm so glad that I was talking to Sean O'Connor a number of years ago, and I told him about my interest in this, and he said that he had a couple that was from Apple that were building a house in Silicon Valley, and they asked him to come up with a circadian solution for their house. And it just didn't exist. And Silicon Valley is aware of it. I did some experimenting with it at Orgatech Omegalux, and kind of abandoned that project. Also, I've proposed this to a lot of people that I've worked with. Definitely have some definite ideas about how this can happen. John and I spent.
You should start a company.
John and
I have a good name.
John and I spent a lot of time on this. I don't particularly want to do another startup. I'd be glad to help in the development of products for those companies that want to do it. It's very doable. It's needed, and I'd like to be a part of it one way or another. Any questions? I bored you to tears?
Not at all.
Thank you.
Just want a few more announcements. There's 2 more IES events that are going to happen first half of this year. One is on April 20th. It's a technical showroom tour at Intense. And then the next one after that is in May 18th, which is the IES Golf Tournament. And then Mitch is here to talk about in November 9th, the lead quake.
Thanks. I think it's pronounced